Welcome. We want to take a look at section 4.6, which deals with graphs of other trigonometric functions. First, we'll take a look at y is equal to the tangent of x. As we begin to look at that particular graph, you'll notice that there's a term called vertical asymptote. And what that term actually means is that the graph does not exist at those values, at those x values. It does not exist at those x values. If you take a look at the tangent function, there's a vertical asymptote at pi over 2 and negative pi over 2. And if we take the tangent of pi over 2, that value is undefined because we have 0 in the denominator. And if we take the tangent of negative pi over 2, that value is also undefined because we have 0 in the denominator. So we actually denote these vertical asymptotes with solid or dashed red lines, and you'll see the graph of the tangent function as it goes from left to right. Here's some characteristics that we need to take a look at as it relates to the tangent function. As we're graphing the tangent function, note that the period now is pi. So when we're looking at one period here, the period is actually equated to pi, and the way we can actually calculate that is we can look at the vertical asymptote here, and we can look at this value and this value here, and that would define our period. So we would actually add pi over 2 plus pi over 2, and that would give us 2 pi over 2, of course, which would be pi. So that's where the period comes from. As you take a look at the domain deals with the x values. We look at the x values. And if you look at the graph itself along the x values, because we have vertical asymptotes, then the graph does not exist at what we call odd multiples of pi over 2. So we have all real numbers except odd multiples of pi over 2. So again, it does not exist at 1 pi over 2, 3 pi over 2, 5 pi over 2, because we have a vertical asymptote. You can also take a look at the range of this function, and the range, of course, will be your y values. And if we look at the y values, we see that it actually goes from negative infinity all the way up to positive infinity. So it would actually be all real numbers. And we'll look at x-intercepts. The x-intercept is going to be the midway point between the asymptotes. So we'll find the midway point between the asymptotes. That's where it crosses the x-axis. And remember, the tangent function is an odd function, so its symmetry is about the origin. We can also plot points along the 1/4 and 3/4 way, which we'll do that as well. So we'll look at 1/4 and then 3/4 of the way as well. Now there are variations as it relates to y equals 10 tangent of x, just as the sine and cosine function. The period is calculated a little different, but first we need to find what we call intervals. So that will be our first thing, and we use this particular formula here to calculate the intervals. The intervals are our asymptotes. Again, it does not exist at these particular intervals. And we use this formula bx minus c to calculate this interval notation, and we'll look at it. The second thing we'll do is we'll define the x-intercept, and again, that's the midway point. And then we can actually plot some points along the graph, and we'll graph one full cycle or one period. as we begin to look at, I'm going to call this particular graph figure, this is figure 479. The graph is shown for 2 full periods. Let's take a look at how do we calculate the interval notation, which will be our vertical asymptote. In this case, our A value will be 2. Our B value is going to be 1/2. So if we actually put it in the formula, -2 less than, remember this is bx minus c, so it's going to be 1/2 x. There is no c value there, is less than pi over 2. So we want to basically solve this for x, so we're going to multiply each term by 2, and if we did that, we have, if we multiply here, we'll have a negative pi is less than x, which is less than pi. So as you can see, at negative pi and pi, we have vertical asymptotes, and again that would define 1 period, and then we just add 2 pi to pi to define a 3rd period there. Let's take a look at the graph on the right. We have our A value is equal to 1, our B value is equal to 1, our C value is equal to pi over 4. So again, we plug that into our formula, negative pi over, be pi over 4. So negative pi over 2 is less than B, which is 1x minus pi over 4, is less than pi over 2, and this time we want to add pi over 4 to each term, and if we did that, if we added pi over 4 to this term here, we would actually add fractions, so that would be 2 pi over 4 negative, and so that would actually give us a negative pi over 4. Let me make sure I'm doing this correctly. That would actually be, if we need to add pi over 4, we would convert that. That would be 2 pi over 4, or negative 2 pi over 4 plus pi over 4. So that would be negative pi over 4 is less than x. And if we add here, this would be 2 pi over 4 plus pi over 4. That would be 3 pi over 4. So we can actually locate our vertical asymptotes there. So we can find out what our asymptotes will be for that particular problem. Alright, let's look at an example here. We'll take a look at this particular example, and the first thing we want to do is define our A value. So A is equal to -1. Our B value is equal to 2. And now we want to solve, and we'll put it in the formula. Negative pi over 2 is less than, this will be 2x is less than pi over 2. That's the interval notation. So we need to solve for x, so we'll multiply by 1/2 each term, and if we did that, we have negative pi over 4 is less than x, which is less than pi over 4. And we can actually, then what I want to do, because we're working on the negative side here, I know that I have pi over 4 is somewhere around here, so I know I have a vertical asymptote here, and then I'm going to extend this out, and negative pi over 4 will be somewhere right in here. This will be negative pi over 4, and this will be pi over 4. And then so I'll take the midway point, and the midway point between the two, which will define it, would be of course x, and then I'll take about 3/4 of it. Now remember, the tangent actually goes from left to right, but when it's negative, it's going to go from right to left. So this will be a value of actually 1 here, and this will be a value of negative 1 down here. So it's going to go from right to left. So have that shape on it, so we can actually graph that. That's what it would look like, and that's one cycle. Alright, let's take a look at this one. We have our A value is 1, B value is 1, and our C value will be pi over 2. So again, we plug it into the interval notation to find our asymptotes. It will be minus pi over 2 is less than, this is going to be x minus pi over 2, which is less than pi over 2. So this time we need to solve the middle term for x, so we're going to add pi over 2 to each term, and if we add pi over 2 here, we get 0 is less than x, and if we add pi over 2 here, we actually get pi. So now we see that we have an asymptote at 0, so it will be the y-axis this time, and we also have an asymptote at pi. So now we can find our x-intercept, which would be the midway point, which would be pi over 2, and then we actually have a positive, so it's going to go from left to right, and about 3/4 of the way we'll actually put a point here, and we'll plop a point down here. So go through these values, and I apologize for my graph. My hand is not too steady with this particular tablet. Alright, let's take a look at the cotangent function. Now when we look at the cotangent, y is equal to the cotangent, which is really 1 divided by the tangent of x. So the cotangent has some certain characteristics about it. Of course, the period is pi, and our domain here will be all real numbers except intervals multiples of pi. Our range will be all reals. We have vertical asymptotes at multiples of pi, and then of course our x-intercept will occur midway between, and then we'll plot some points at 1/4 and 3/4 of the way. Of course, this is an odd function, so its symmetry is about the origin. And the variations actually worked similar when we look at the variations of the cotangent function. We actually take, rather than using the same variations that we use with the tangent, we actually use 0 and pi, and then everything else pretty much applies the same, so we can actually graph that function. Now if you note, the cotangent is going from right to left, so it looks almost as if it's the negative tangent. So it's the negative of the tangent itself, so it goes from right to left in that fashion, as opposed to left to right. Alright, let's look at an example of a cotangent. We have y is equal to negative cotangent pi over 2x, so our A value is 1, our B value would be, this is actually going to be pi over 2, and there is no C value. So again, we plug this into 0 is less than, the formula is bx minus c, so it's going to be pi over 2x is less than pi. So that's the set interval, and we're actually, what I'll do here is multiply each term by 2 over pi to eliminate the pi over 2 in the middle term. Of course, I have 0 here, x here, and then my pi's cancel, and I have 2. So that tells me I have a vertical asymptote now at 0 and 2. And then if I want to plot my x-axis, it's actually a midway point. Because it's negative, what happened with the negative cosine, it looks similar to the positive tangent. So I'm actually going to find a point here and define a point here, and it actually goes in that direction there. So that will be negative cotangent pi over 2x. Okay, let's look at another example. We have A is equal to 1, B is equal to 1, and C is equal to pi. So again, we're going to put it between the intervals. This is going to be x minus pi, is less than pi. And what we're going to do here is we're going to add pi to each term. And if we add pi here, we have pi is less than x. And if we add pi here, we have 2 pi. So now we see that we have a asymptote at pi and at 2 pi. And then our midway point will be 3 pi over 2. This is a positive tangent, so it's going to go from right to left. So I'll go about a fourth of the way and locate that point, and here, and locate this point here. So it actually comes down and through this point here. And so that kind of gives you, and all we're doing is just sketching what the graph actually looks like. So it gives you an idea of what the graph looks like. Here's another problem, and I'll let you continue to work through it for any further examples. Now we want to take a look at the reciprocal function of the sine and cosine. So here we have y is equal to the cosecant of x, which will be the reciprocal of the sine of x. So if we take a look at the characteristics, we have the period, which is 2 pi, which is the same. Now we do have the domain is different because, again, we actually have 0 in the denominator at certain values. So we have all real numbers as a domain except multiples of pi. And then the range, of course, what happens with the range, because the graph actually peaks out, it uses the max and the mins of the sine graph. The range is going to be greater than 1 or less than -1, and we can write that in set notation. It's going from negative infinity, and it's including -1, and it's also including 1 to positive infinity. And then of course you have vertical asymptotes at pi, and then it is an odd function, so its symmetry is about the origin. The secant function, we take a look at y is equal to the secant of x. It's the reciprocal of the cosine, so it's the same as 1 over the cosine of x. The period will be 2 pi. The domain will be all reals except odd multiples of pi over 2, again because it actually does not exist at pi over 2. The range will be all real numbers such that y is less than -1, less than or equal to -1, or greater than 1. And set notation is going from negative infinity, including 1, and it also includes 1 to positive infinity. Vertical asymptote, the odd multiples of pi over 2. That will be 1 pi over 2, 3 pi over 2, 5 pi over 2. And the secant is an even function, just as the cosine, so its symmetry is about the y-axis. And let's take a look at some variations here. So if we look at what the calculator is actually doing, what I want to do here is I want to bring up the TI, if you will allow me to bring up the TI-84, and I want to essentially graph these functions so you can actually see how to input these functions into the calculator. So I'll bring that up, and I'm going to close out this screen, and let's go y equal. Now we want to actually enter, remember the cosecant is the reciprocal of the sine function, so I want to put both graphs on the calculator. So I'm going to graph this as y is equal to 2 sine of 2x, and if I actually just do if I change my window settings, I'm going to change my window settings to match that on the screen. I'm going to go from -pi all the way to pi, and then I'll use intervals of pi over 4, and y min will be, looks like that's going to be -5 up to +5. So if I actually graph that function, that's the graph of the sine. So let's look at the cosecant. I'm going to put parentheses around the sine function, and what I'm going to do here is you're actually going to have a double set of parentheses, one to close the sine function and one to make it the inverse. So I'm actually going to make it the inverse. Your calculator may look a little different. It depends on what operating system you're working on with the TI-84. If you're working on the latest operating system, it will drop down and look similar to mine. If not, yours should be okay as well. So we're going to graph this function. So if you notice here, there is the graph. Let me see if I can bring it in. Okay, there it is. So they're both graphs here. So I actually have this particular graph here is going to be my cosecant, and that's my y2, and this graph here is my y1 there. If you look here, what ends up happening is what becomes a max is actually a min point for the cosecant, and what becomes a min for the sine is actually a max. And I can kind of put some vertical asymptotes in here, and here's one at 0, and here's one here, and here's one here. So you kind of see where the vertical asymptote lies as it relates to this particular function here. We can also do the same here using the secant function. So I want to bring back my calculator, and let's graph this function. I'm going to clear this out, and my y1 function is going to be, I'm just going to go with the regular cosine, 3 cosine, this is going to be x divided by 2, and then I'm just going to drop down my y2 is going to be negative 3. I'm going to put this function in parentheses, x divided by 2. I need to close both sets of parentheses to the minus 1. So that's that particular function there, and then I'll graph it. It may not look like what's on the screen because I need to change my window settings. I'm going to make my x min negative pi, which I'm actually getting from the graph. I'll make my x max 5 pi, and I'll make my scale looks like pi, and my y min will make it negative 6, y max will be positive 6, and then we'll graph it. So now it should look something similar to that particular function there. So again, the actual secant, the secant function is the reciprocal of the cosine. So we actually use the cosine to graph the secant function, and we find these points. This one says first graph the y sine 2x and then graph its reciprocal. So I'm going to bring up the calculator again to help us with this one. So we'll clear these out, and we'll have y is equal to the sine of 2x. We'll drop down for y2. I'm going to put the sine of 2x in parentheses and take it to the minus 1, and that's going to be my formula. And then I'm actually going to change my window settings. I'm going to make x min 0, x max 2 pi, and then my scale, I'll make it pi over 6, and then my y min will be negative 2, y max will be 2, and then I'll graph the function. So that's what the graph actually looks like. And I can take this and potentially blow it up just a little bit so you can see it. And so there's your graph. We also want to graph this particular function here. Let's take a look at this one. We'll bring up the graphing calculator. Again, I encourage you to take advantage of the graphing calculator. There are tips and programs out there that may enhance your learning ability of the graphing calculator. As I see a need to learn other functionalities of the graphing calculator, I will provide you with those tutorials. So here we want to graph 2 cosine of 2 pi x, and we'll drop down here and we're going to put the cosine in parentheses. Make sure you don't include that 2 in parentheses, just the cosine, and x with double parenthesis here to the minus 1. I do apologize for my cold here. I'm having some type of battle with something, and giving me the sniffles here. So we'll make the scale 1, and x y min will be -3, y max will be 3. And we'll graph that function. So as you can see, that particular function has several, and it really looks really weird, but we can actually look and we can begin to define the max and min points along here, right in this area right in here. Let's see what it looks like. So again, there are 6 curves, and we just want to give them the rundown real quick. We looked at the sine, cosine, tangent, cotangent, that's the cosecant, and the secant function. Now this says this graph is what function, and we can kind of narrow it down. We know that the cosecant is actually going to give us a U shape. We know that the secant is going to give us a U shape. And now it's either going to be cotangent or negative cotangent. Remember, cotangent actually goes from right to left. Negative cotangent goes in the direction of the tangent. So sometimes it's hard to distinguish the difference between the negative cotangent and the tangent. And so we have to maybe do some further calculations to provide that distinguish. All right, here we want to take a look at find the reciprocal function, whether it's the cosecant or the secant function. If we look at this particular function here, this is actually a sine graph, and it gives us one period, and we can actually establish from here to here is a period. So a period here is pi over 2. We can also find A, and use this area right here, the maximum point to find A. So A is equal to 3, and the period is equal to pi over 2, which is equal to 2 pi over B. And if we solve this in terms of B then will be 4. So now we know the B value, so we'll plug that into our formula. Y is equal to 3, and if it's cosecant, it's going to be cosecant of 4x there. So that will be the only one. So it's the reciprocal function there. That will be the final. So this concludes our section on 4.6, and I will provide you with a homework set as well. And if you have any problems, please feel free to email me.